Namaskar, hello, and once again a very warm welcome to CIET NCERT's 5-day online training. And this theme of this training is developing e-content for teaching and learning of mathematics. Today we are entering into day 4 and our today's topic is developing e-content for teaching and learning of three-dimensional geometry. So far we have discussed that how technology is so important for mathematics, what is the need, scope and free open source softwares, and we also discussed the features and possibilities of GeoGebra, and we also discussed on day 3 about the two-dimensional geometry. So today we are going to discuss more about three-dimensional geometry. Please participate in this program. Please register yourself. My name is Tanvi Khurana, and let me just give you a brief about this entire online training. This started on 21st of August, that was Monday, and it is going to be there till tomorrow, which is 25th of August. So every day from 4 to 5 we conduct one session based on a different topic, and we always have one expert and they discuss each and every detail of the topic. If you have not seen the earlier programs, I would request you to please watch them. And at the end of the day, at the end of the week, that would be tomorrow, after the program, we'll be releasing the quiz link. And if you can participate in and score more than 70% marks, you'll be eligible for the participation certificate. For the certificate, please allow us 30-day time to release those certificates because we get a large number to prepare. That's about that. If you have not registered yourself, I am going to explain the process towards the end of the program. Please watch the entire program for that briefing. And also, this entire online training has been organized by Central Institute of Educational Training, NCERT, New Delhi. So before we begin this program, I'm going to tell you that there are so many ways through which you can connect with us. Either you can share your questions through our email ID. We have one specific email ID, that is training.helpdesk@ciet.nic.in. If you want, you can even raise your questions through the call. The number is 8800440559. You're watching us on eVidya channel number 6 to channel number 12, and also on our YouTube channel, that is NCERT Official. In the live chat box, raise your questions, queries regarding this topic and share them with us. You will be answered for sure towards the end of the program. Now let me please introduce you to our guest for today. We have with us Mr. R. Ramanujam. Sir, a very warm welcome to you.
Thank you.
Thank you.
Thank you.
Sir is a postgraduate teacher from MNKM Government Higher Secondary School, Pulapatta, Kerala. And sir, it's a pleasure that you are here with us today, and you'll be explaining about three-dimensional geometry. We'll begin this conversation very, very soon. Just one last announcement I have to make for all our viewers. We are extremely proud of the fact that India assumed G20 presidency and would convene the G20 Leaders Summit for the first time in the country this year, that is 2023. A nation deeply committed to democracy and multilateralism, India's G20 presidency would be a watershed moment in her history, as it seeks to play an important role by finding global, pragmatic solutions for the well-being of all, and in doing so, manifest its true spirit of Vasudhaiva Kutumbakam, or should I say, the world is one family. Vasudhaiva Kutumbakam also translates to one earth, one family, one future, and that is exactly the theme of this year's India's G20 presidency. For this training, every last week of the month, we conduct this training on development of e-content. So for this week's theme is development of e-content for teaching and learning of mathematics. Let's begin this conversation, and let me ask Sir, we have so far discussed a lot of things regarding GeoGebra, but three-dimensional geometry is still pending. So can you please help us with this and let us know how a user can operate it, sir?
Thank you, Tanvi. Thank you for the invitation. First of all, there is a slight change in the topic. Okay, three-dimensional geometry will be discussed Today we are dealing with calculus. Okay, so no problem anyway, because calculus, we know calculus is the mathematics of change. So it's so important. That is why we select calculus. We selected calculus as a topic for the discussion. Okay, and yesterday at the same time, we the Indians were in our happiest moments because of the victory of Chandrayaan, and we know that that victory is a victory of science, and it is a victory of mathematics, and definitely it is a victory of calculus, because calculus is the mathematics of motion. And because of the same reason, a dynamic software like GeoGebra can do a lot in calculus. That is why we selected this calculus as a topic for the discussion. And today, within the limited time, I will try to showcase some examples. Okay, so start. Can I start, Tanvi?
Yes,
My
sir. Please,
presentation?
please.
Okay. The basic of this calculus is the concept of taking limits. We are teaching this concept limits from the plus one, the 11th standard onwards. But even before that, we are dealing with this concept, taking limits, without any technical jargon, without even saying that name, taking limits. Okay, so let me start from there. Okay, I will show a GeoGebra applet. It's a already made applet. Can you see the screen? A circle and a polygon in it.
Yes, sir.
Can you? Yeah. Okay. So the basic problem is, we know how to find the area of a triangle, or area of a polygon, or area of a quadrilateral, or area of any polygon. We can divide the polygon into triangles. But in the case of a circle, it is not possible to divide the circle into triangles, because the boundary is not a straight line. Okay. So the basic problem is, how can we find the area of a circle? We all know that it is pi r square. I am trying to show how that pi r square is reached. I am trying to derive that using the concept of taking limits. Okay. So here we have a circle here, and a polygon, a regular polygon is inscribed here. Since it is a regular polygon, we can change the number of sides using. We can change the number of sides of the polygon using a slider. Okay, I will show how can we make that slider. And now we cannot distinguish the polygon and the circle. So our aim is to derive the area of a circle as the limiting, technically as the limiting case of area of a regular polygon. Okay. So for the convenience, first of all, we will find the area of this triangle. Okay. It's very easy. We know how to find the area of a triangle. Half BH. So we all know it, where B is the base and height is H is the height. Okay. So instead of H, it is given X. So area of triangle is half B into X, if B is the base. So area of this entire polygon is the area of a single triangle into number of triangles, or it is same as number of sides. So we can find the area of polygon as like this. It is half bx into n. N is the number of sides. Okay. We can rewrite it as half x into bn. No problem. Yeah. And b is the length of one side of that polygon. So bn is nothing but the perimeter of that polygon. So we can replace bn with the perimeter, and p stands for the perimeter. So now the area of this polygon is half x into p. Now let us see what happens to this x and to p as we increase the number of sides. Okay. As we increase the number of sides, x is approaching to the radius of the circle. So we can replace x by r. And P is approaching the perimeter of the polygon, P is the perimeter of the polygon that is approaching the circumference of the circle. So in the limiting case, we can write it as half r x becomes r and P goes to 2 pi r. So half r into 2 pi r, and it is equal to pi r square. Okay. So for deriving this area, this formula pi r square, we are using the concept of taking limits. Okay. I will explain how to construct this applet, but before that, the same idea is using in 12th standard, why we deal with area and rectangle. Okay, I will do it with a fresh GeoGebra window. Suppose we want to find the area under the curve x square. Okay, x square. So here the curve is x square. Suppose we want to find the area under the curve x square above the x-axis between 1 and 2, between x equal to 1 and 2. We can divide that region into rectangles. We know how to find the area of a rectangle. So we are going to divide that region into rectangles. Okay. And if we increase the number of rectangles, we can find an approximate value of the area. So for that, we are starting our construction. First of all, that in order to increase the number of rectangles, I am creating a slider. It is a tool slider. Okay. Slider. Just click anywhere in the graphics view. I am selecting the option integers. Okay, because this slider stands for the number of sides of number of rectangles. So it's an integer. It's a natural number. Okay, maximum is by default it is 30. We can change it as 100 or whatever it may be. Okay. So this is our slider. We can change it from 1 to 100 because the minimum is 1 and maximum is 100. We can fix it anywhere in between 1 and 100. Let it be 7 or 10 or 9. Okay. Now there is a command, lower sum command. I will show the command again. Now I am typing this command, lower sum. The first entry is the function. We can either type x square or the name of the function f. Start value 1 because we want to find the area between 1 and 3. The n value is 3 and the number of rectangles is n. Okay. N is the name of that slider. So here we get 9 rectangles. Now the value of n is 9. Here we get 9 rectangles, and here we can see a number a equal to 7.79. It is the area, total area of the rectangle. As we increase the number of rectangles, we can see that the area is approaching the area of the region that we require. Okay. So in this case, we cannot distinguish between the curve and the rectangles, but even then, there is a gap. If we zoom somewhere here, we can find that gap. Okay, but still, we can increase the number of rectangles. So it is nothing but the process of taking limits. So this is the method of finding, and we know that we can find the area directly using the integral command, and I will introduce that command also. Integral, give the name of the function f, and the start value is 1, end value is 3. That gives the definite integral of the function x square between 1 and 3. Okay, I will show it. So it is the exact value is 8 point, may not be exact, rounded to 2 digit. It is 8.67, and we can find the same as the limit of a sum of areas of rectangle. Okay, now I will show the commands that I used here. For typing x square, this is the command. Okay, x square. I have used the command lower sum. Lower sum, f is the name of the function. 1 is the lower limit and 3 is the upper limit, and n is the name of the slider. Okay, and there is one more command, upper sum. Okay, you try that command upper sum and try to find the difference between lower sum and upper sum. And for getting the definite integral, the command is integral f comma 1 comma, that gives the definite integral of the function f between 1 and 3. Okay, so in this manner we can start the discussion of limits. Okay, now let us move to another one. See, we can use this definite integral command. We have already find it. We can use this definite integral command to find the area between two x values under a curve, and I will take the construction again. Okay, suppose we want to, I am going to change the function. I will start with a new function. Suppose we want to find the area of the function x square, area bounded by the graph of the function x square minus 3. The function is there between minus 3 and 3. Okay, say, let it be there. So the command is integral, name of the function f, start value minus 3 and end value is 3. Okay. So we can see the region here. We want to find the area of the region, but the value of the definite integral, as you can see, it is 0. Okay, how it happens? So there is a region there. We can find it in front of us. There is a region, shaded region, but the value of the integral is 0. So keep in mind that the definite integral always will not give the exact area, and the reason is that we know that if the curve is above the x-axis, the value of the definite integral will be positive, and if it is below the x-axis, it will be negative. And in this case, fortunately or unfortunately, these values are getting cancelled. The positive values, two regions above the x-axis, and there is one region below the x-axis. These values are getting cancelled. Okay. Then how can we find the required area? That is our question. If we are doing this problem with our actual method, we have to divide the area into 3, from minus 3 to this point, okay, where the curve cuts the x-axis. Then from this point to the second point, the value of the definite integral will be negative, so we have to find the modulus of that, and from this point to the last point 3, okay, and we have to add all these values taking the modulus. But with the help of GeoGebra, there is a shortcut for this. Okay, see, I am using the command integral Instead of the name of the function, I am using the command absolute value of that function. The command is abs of name of the function is f. Okay, that means we are trying to change the function with its modulus. Okay, and start value is again -3, end value is 3. Okay, so we get another curve. See, so instead of the original function, we are using the modulus of that function. So this is the function is minus f. I mean the mod f is the function. You can draw the graph of the function also. So from here we can find the exact value, the required area. It is 13.86. You can see it there. Okay. So this is the advantage of a software, because you cannot do this with in your usual methods. Okay. So let us move to now. Let us move a little more. We are going to get the idea of limit of a function. Up to this, we are dealing with the process of taking the limits. Now, limit of a function, we know that limit. We know the method of writing. We know the notation. Everything we know. So we know that limit x approaches a fx is, as x approaches a, if fx is approaching a particular number, that number is the limit. Okay, so we write it as so limit x approaches a fx. If it is L, we know thus that as x approaches a, the value of the function fx will approach the real number f. Okay, let us try to do it geometrically. So let us open another GeoGebra window. See, here you can see that the function is fx equal to x square for x less than or equal to 2. And it is defined as 2x plus 1 for x greater than 2. Okay. You can find the value of x on both sides of 2. 2 is here. On both sides of 2, x is not. And the corresponding values of the function fx, you can see them on the y-axis. See what happens if x approaches 2 from both sides. Okay, with the help of this slider, x, we can change the position of x. X is approaching 2 from the right as well as from the left. Okay, now what happens to fx? For the value, let us keep it here. See, this is the value of fx corresponding to x on the left side of 2. This value is approaching 4 and the right value is approaching 5. You can see. Okay. And we will say that the left limit is 4 and the right limit is 5. So the limit will not exist here. Okay. Now, if change the function slightly, as instead of 2x plus 1, I am changing it as 2x. So the function is fx equal to x square for x less than or equal to 2 and 2x for x greater than 2. Now what happens to fx? As x approaches 2 from both sides, we can see that fx is approaching 4 from both sides. Okay, so in this case, the left limit as well as the right limit is 4. So the limit is 4. Okay, so let us try to construct this. I will demonstrate it. Okay, so we can start from a new GeoGebra window. Okay. First of all, we have to draw the graph of function. So let us start with the x for convenience. Okay, we can start with x squared. To change the position of x, we need a slider named h. So we are going to create a slider. Name it as h. We can change the name with minimum value 0 and maximum value 1 with increment that will be 0.01. Okay, let it be done. Suppose we are going to discuss the limit of this function at the point 2. So we want 2 points, one on the left side and one on the right side of 2 that approaches 2 by the control of this slider. So I am defining 2 points on x-axis. Okay, so I am defining a point. Its x coordinate as 2 minus h. H is the name of the slider, comma 0. Okay, so that point will be on the left side of 2. We can see that point there. Okay, the name of that point is A. And another point, and we need another point on the right side of 2. Okay, so it is 2 plus h, comma 0. We get another point, 2 points A and B, one on the left and one on the right of. And we have to find the corresponding points on the graph as well as on the y-axis. Okay, the point on the graph will be, see, the name of that function is f. So the point corresponding to A will be, its x coordinate is 2 minus h itself, and the y coordinate will be the value of that function f of 2 minus h. Okay, so we get a point on the graph. And the corresponding point on the y-axis, we have to draw a horizontal from C to the y-axis. Instead of that, we can plot the point. Since we want a point on y-axis, its x coordinate will be 0 and the y coordinate will be the image of that function. So f of 2 minus h. Okay. In a similar manner, you can construct points corresponding to B. The construction is say, I am going not going the details, but details. Okay. Now you can connect these points using segments. You can include some text. X here. So you take the tool for text, click on A, then only that text will move with A. Just enter X. Okay. Text is there but may not be visible. Okay, it is behind that. Okay, this is our X. We can change if you want. We can change the font size or its size or its color. Everything is possible here. By right clicking and going to object properties, you can change the color. You can change. You can make it bold. You can make it, you can change its size, everything is possible. Okay. Similarly, you can insert a text to this point, fx. Okay. Same way. And now let us see how it works. If we increase the value of, decrease the value of h from 1 to 0, that x is approaching 2. Okay, from the left side. And fx, you can add a text fx here. Okay, fx will be here. So, as x approaches 2 from the left side, fx approaches 4, as we know. Okay. Now, in our example, we were discussing the function fx equal to x square for x less than or equal to 2 and 2x for x greater than 2. It is a piecewise defined function. Okay. So, how can we draw the graph of such a function? See, I am editing this function. Now it is x square only. We can edit it as, we have to insert a condition, if condition. If x less than or equal to 2, comma x square, comma, otherwise it will be 2x. Okay. So, this is our new function, or you can edit it again. If we want 2x plus 1, just change 2x plus 1. So, with a single applet, you can see, you can show the existence of limit, non-existence of limit, everything you can show. Okay, I will show the command once again. This is the if command. If x less than or equal to 2, x square, otherwise 2x plus 1. We can read it as, if x less than or equal to 2, comma x square. That means if x less than or equal to 2, the function is x square, comma 2x plus 1, which stands for otherwise the function will be 2x plus 1. In the remaining domain, it will be 2x plus 1. Okay. So, see, we have introduced, in Kerala, we have introduced IT-based mathematics lab for in higher secondary curriculum, and we have prepared manuals for +1, +2, and handbook. And these are available in the website of ACRT, Kerala, acrt.kerala.gov.uk. So many activities are given there. Okay, if you are interested, you can download these books. Okay. Now let us go to the next one. And if you are familiar with the Epsilon-delta definition, I will show an applet of that. I'm not going to construct it because it will take time. Okay, but you can try. See, if you remember the Epsilon-delta definition, for any epsilon greater than 0, so this is a circle of radius epsilon. Okay, we have a slider to change the value of epsilon. There exists a delta greater than 0. So this is a delta circle of radius, such that every point in that delta interval will be mapped to the epsilon interval. Okay, so you can, for this corresponding to this epsilon, you can find a delta like this, so that all the points inside this circle is mapped to the epsilon circle, or epsilon in the case of two-dimensional, it is epsilon interval. Okay, so you can try to create such a, it is not difficult. Okay, and we will get the concept of limits by just observing some graphs. So let us discuss uh, some graphs. Let me draw the graph of the function sin x. The command is, it's a direct command. You just input sin x in the input bar. You just type sin x and enter. Sin x. So the spelling is wrong. Okay. So we get the graph of sin x. And I am drawing one more graph. It is nothing but the graph of fx equal to x. Okay, fx equal to x. Now, let us zoom the graph at the origin. Let us see what happens here. See, we can see that at this position, we cannot distinguish the graph of sin x and x. Both are there. Okay, this is the graph of sin x, and this is the graph of x. Both are there, but we cannot distinguish between these. Okay, what is the inference? We are zooming at the origin. That means we are going close and close to 0. Okay, so as we go more and more near to 0, sin x and x, the values of sin x and x are almost equal, and that gives the limit, the well-known limit x approaches 0, sin x by x is 1. We know this limit. Okay, so this is a simple visualization of the particular limit. Limit x approaches 0, sin x by x equal to 1. Okay, and let us try another one. I am drawing the graph of sine of x squared. Sine of x squared. Okay. And again, one more graph, x squared. It is x squared. Now let us zoom the both of the graphs at the origin. What happens? Again, we can see that they coincide each other. That means limit x approaches 0. We know that limit x approaches 0. Here, one of the functions is x square, and the second function is sin x square. So limit x approaches 0, x square by sin x square, or sin x square by x square. That limit, both the limits are 1. Okay. Now let us try with one more function. Along with these graphs, I will try sin square. See, one more graph is there. Okay. This is sin square x. So now we have two graphs, sin square x and x square. Again, we can zoom here. Actually, they are not coinciding. They will meet only at 0, but their values are getting more and more close. Okay, so again we can derive a limit from this visual. Limit x approaches 0, sin square x by x square equal to 1. Okay, so let it be there. We will move to one more. Again, we will move to the first visual. let us draw the graph of sine x and x. Okay, we can see that they coincide at the origin. Suppose I change the definition of this. Now it is x. I'm going to change it slightly, and because to change for convenience, we can I will introduce another tool. There is a tool, input box. Okay, input box tool. Take that tool and click anywhere in the graphics view. You give any caption. So let it be function. Function, and I am going to link that function gx equal to x with this input tool. Okay, with the help of this tool, I can edit the function. So I am editing this function. Now it is x. I am editing this as x minus x cube by 3 factorial. Okay, see what happens. See, now this, and we know that it is a polynomial. Okay, fx sin x is a trigonometric function, and x minus x cube by 3 factorial is a polynomial function, and that coincides with sin x in more areas. Okay, again I am going to edit the function as x minus x cube by 3 factorial, and again I will add one more term plus x raised to 5 by 5 factorial. 5 factorial. Okay. So that covers more portions of sin x. Then x raised to minus, you know the expansion. X raised to, next time will be x raised to 7 by 7 factorial. Okay. It covers more and more portions of sin. But we can do it with the help of a slider also. There is a single command for that. For that, I am creating a slider, an integer slider. Integer slider. Okay. Then there is a command, Taylor polynomial, for the function sin x. So here our function is sin x of f. At 0, I want to get a Taylor polynomial at 0 and order number n. Okay. So I will hide the previous one and text, and this is our new function. Now with this command, if I change the value of n, we will get the Taylor expansion length. Okay. So we know that we can express sin x as the sum of this infinite sum of this polynomials. Okay. So it is we will get that by a simple command. I will show that command, Taylor polynomial of sin x, or you can give f. So you can give any function at 0. N stands for the order.
Okay. So we have last 5 minutes left.
Oh, okay. So our time is limited.
Yeah.
So I will just show one more example. Up to this, we were dealing with limits. Okay. So let us move to derivative, and for that I will show a simple example. And we know that derivative of a function at a point is nothing but the slope of tangent to the curve at that function. But people might have a misconception about the tangent to a curve. They may say that tangent to a curve at a point is that line that just touches the line at that point. not cutting the line like that. Okay, but it's true for in the case of a circle or ellipse, but it is in general it is not the case. Okay, uh, so we can show this with the help of a smaller letter. I am drawing the graph of sin x. Sin x. You take any point in the graph, and we have a tool, tangent tool. Okay, it's available in the fourth set of tools, tangent tool. Using that tool, you click on this point and click on the curve, you will get a tangent. Okay. Now, this is a tangent to the curve at the point A. But we can see that it cuts the curve again at somewhere. Okay. And if we bring this point to the origin, we can see still again it is the tangent to the sine curve at the origin, but it cuts the curve at the point itself. Okay, so tangent is not the line that just touches the curve at that point. Then what is a tangent? Again, we can describe a tangent in the limiting case of another line called secant line. Okay. A secant line is nothing but I am taking one more point. Okay. So we now this is the tangent line that required. Okay. Here the problem is we know the point A, but a single point we cannot determine a line uniquely with a single point. We need some more else. Either we need a slope or one more point. Okay. For that, we are taking one more point on the curve, and we are drawing a line joining A and B. Now, 2 points are there. So this line, it is called the secant line. It is uniquely determined by these 2 points. Okay. Now, I am bringing this point B towards A. At any stage, this secant line is defined because we have 2 different points. What happens to the secant line as B approaches A? The secant line coincides with A. If I do it from the left side of A, then also we can see that the secant line coincides with the point A. So we can define a tangent geometrically. A tangent to the curve is the limiting case of a secant line. Okay. Now, I think we can go a little bit more within 1 or 2 minutes. After that, I will stop my presentation.
Yes, can you briefly explain the rest of the thing and wrap it up, because we are very short of time right now.
Okay. I will hurry up with that. See, suppose we want to describe the tangent at the point P. We are going to describe it in terms of derivatives. Okay, that's our aim. We are taking another point, and we know that the derivative was at P. F prime x is x is the x coordinate of P, so f prime x is limit h approaches 0, f of x plus h minus f x divided by h, that we know, and P is the point x f of x. Okay, so we are taking another point on x-axis, x plus h, and the point on the curve corresponding to let it be q. corresponding to this point, and its coordinates will be x plus h, f of x plus h. And we know we have 2 points and we know their coordinates. We can join these 2 points to draw the secant line causing to P and Q, and we know that the slope of this secant line, we know it is y difference f of x plus h minus fx divided by h. And we know, as we have seen it, as Q approaches P, h is approaching 0. Okay, the difference is approaching 0, and the slope of PQ is approaching the slope of tangent. So the slope of tangent is the limiting case of slope of secant line, and that is nothing but limit h approaches 0, f of x plus h minus fx divided by h. Okay.
Okay.
So I am not going to construct this.
Yes.
And you can try it. Okay. So I am just.
I think our viewers have got the idea that how they can operate it. So thank you so much for being with us today. I'll just ask one little question. So were you operating this with the help of the browser, or did you download the app?
I didn't get your question, ma'am.
So are you operating this from the browser, or did you download an application for this?
No, all these applets are created by our team. Okay, anybody can create it. GeoGebra is very user-friendly software, and with a little knowledge on that, you can create all these applets. Okay, I have shown some constructions in front of you, and it is very user-friendly. Okay, I am on these applets, the applet that I have shown in the last one. It's a ready-made applet created by us.
All right. Thank you so much, sir, for being with us today. It was wonderful talking to you, and we did get an idea of how one can develop the e-content for teaching and learning for calculus. Thank you so much, sir.
Okay, thank you. Thank you.
Thank you to all the viewers as well. This was our program on calculus, and tomorrow we'll come back on our another day 5's topic, and that is going to be developing e-content for teaching and learning for three-dimensional geometry. So let me please explain you the process, how you can be a participant in this program. All you have to do is open any browser, type CIET on it. Once you do, a home page will open like this. Please have a look. The home page is this, and you can see in the menu bar there are so many options. In the events option, the third last option is workshop/training. Once you click on it, then another page will open. Just scroll it down and click on the current activity, which is our online training going on. This is everything regarding our online training. The schedule has been mentioned, the topics, the reason why, how is this training important, the objectives behind it, and each and everything. So scroll it down. Here you can see a QR code and scan it and fill the form. Please make sure that you are entering correct information. And here is another link. Once you click on it, fill the form, and you can be a participant. Please make sure that you are writing the correct spellings of your name so that it will be easy for us to prepare the certificates. Once you scroll it down a little further, you can see this is the space where the quiz link will be released tomorrow after the session. So you will be eligible to participate in that. Once you score 70% and above marks, you will be getting the participation certificate. You can see this link. Once you click on it, all the earlier sessions that we have done on day 1, day 2, day 3 are there already. So this is the link. You can watch all the programs simultaneously, and you will get an idea about the answers that you need regarding the quiz. Here is the feedback form. Please fill the feedback form. If you have any suggestions, any advices, you have any topics for us to discuss in the later programs, please advise us. And lastly, if you scroll it down, this is our specific training email ID, training.helpdesk@ciet.nic.in. Raise your questions regarding this online training on this particular email ID, not just within the time frame of this program, but later on as well. So this is everything about our training, and day 5 we are going to come back here sharp at 4 o'clock on the same platform, that is NCERT official, and the topic is going to be developing e-content for teaching and learning of three-dimensional geometry. Thank you so much once again for being with us, and I really hope that you have a great day ahead. Before leaving, just want to remind you once again about the NCERT textbooks that are available throughout the country for this new academic session. You can read the information in the form of ticker. It's being shown on your screens at the moment, and we try and display this information in each and every program of ours. So please buy those textbooks very, very soon. Thank you so much. I'm Tanvi Khurana. I'll take a leave of you. Namaskar.